What's up, y'all? This is Jesse Warden. Today we're going to cover unit testing in JavaScript utilizing Jasmine. We're also going to cover why unit test in the first place. So what is unit testing? Well, unit testing is taking a unit of code and making sure that it works in a repeatable fashion. And what that means is that when you add new code or modify it or delete it, you don't have any guarantee that the code that you used to have still works. Yes, we as developers strive for encapsulation and loose coupling and things like that. However, because of deadlines, changes in requirements, multiple people that don't always effectively communicate, whatever, your code can break over time, even code that was working fine for a while. So there's two ways you help solve that through regression testing, and that is a bunch of logging to indicate what went wrong, what didn't, as well as unit tests. And you do it in something called coverage. So if you have enough unit tests covering enough of your classes and methods that you can run really quickly, anytime you add new code, modify new code, or delete code, you can run those tests and verify that your change or addition or modification did or did not break anything, usually. Now, it depends on how much coverage or how many unit tests you have over a large area of your code. But that's the theory of it, right? And the reason that it's important in JavaScript is twofold. Number one is that just like any other client-side technology, it has to talk to a server to get its data. And because it's getting data that's not in its native form, it doesn't know what it is. So even if it gets a JSON object, it could sometimes get a JSON object that's missing a node, and that could result in a null pointer. Or the date could be formatted wrong. Or it could get a 500 response as HTML rather than JSON. Right? There's all kinds of things that could go wrong when you talk to a server. So you want to validate that communication or that set of data that you're working on in your system, VOs, DTOs, whatever, is totally legit. The second reason is just that your classes actually work. So if your models or your factories or your services are expected to perform a certain way, you can have unit tests around them and make sure that they work. And eventually, you can have your entire system run in something that's called a CI or continuous integration. So when you check in code, it runs these tests every time somebody anywhere checks in code. If it fails, it says who it was and where and what exactly broke. And it's a great way to have the health of your code stay good. Because of JavaScript's lack of typing, unit testing tends to have more of an importance because as your code grows, things like static typing are non-existent. Everything's a variant, and JavaScript has a very loose type system as well as with equality and all of the other quirks, not to mention the fact the cross-browser environment. So when you add in the fact of multi-browser, multi-OS, and multi-device, the only firm platform you really have to stand on is not the language, but your unit test on your code base within that language. So those tests will help you verify if things work or do not. And the larger your code base gets, the more devices you target, etc. Right? Especially if you have large teams as well, when you're having developers work with other people's code, as well as all these libraries that work on top of libraries. So you can see that unit tests are really, really important for JavaScript. And now that the war of client server is over, because a lot of the ways of getting, you write once, deploy everywhere. HTML doesn't really do that depending on how large the scope is. But if I want to write an app and I want to write it once, HTML, most devices have some form of browser. So if somebody's going to visit my site every week and I want to guarantee that they can see it, whether it's Roku, Xbox, Android, iPad, whatever, if I do an HTML application or website, then I can guarantee that for the most part they can see it, depending on the content and the features of that device, right? You're going to do a lot of client-side scripting to help ensure that the client only has to do a few HTTP requests rather than a bunch. That instead of server-side rendering HTML, you're only doing single like data requests. You're not actually re-downloading interfaces, right? You preload all that on the client and dynamically build it, right, through templates. So as your JavaScript, increases, you're going to have a lot more code. And unit tests are one way, next to good architecture and good OOP and all the other basics, are one way to ensure that you have a large code base that can continue to work and you actually know if it's working or not, right? So that is why unit test. So let's talk about what is Jasmine. Jasmine is a unit testing framework and test runner that basically works out of the box for JavaScript. They have a wonderful website here at pivotalgithub.com/Jasmine, and all the docs are here. So just to give you a high level, their version of unit test suites are called specs. So it's specs or suites, same thing. They label it as describe, but basically anything that's described function is a test suite, right? So you can have a series of tests inside here they say a suite, and when it runs in this function, it'll run all these tests. Tests are started with the function called it, and they kind of do this BDD or behavior-driven development type of thing. Smells just like Ruby people, where they say a suite contains a set with an expectation, right? So that's an it function is basically a test. It has a name or a sentence that's printed out, and then the function that actually runs the test. And you nest these tests inside the described function. Like everything in JavaScript, they're obsessed with closures. They don't care about the overhead that creating inner function creates. They don't care about garbage collection. They just care that you have functions with the functions that can be changed, and it's so functional. Oh my God, I'm a functional JavaScript programmer. It is what it is. You get used to it. The third thing that Jasmine has is a wonderful set of matchers. So if you're used to assert, they call it expect. So I assert that true to be true, right? It's very similar to Hamcrest if you're used to that from Java or ActionScript 3. And the reason their asserts are really nice is that they have some JavaScript specific ones. So for example, 2 equal, 12 for numbers, that's great, matching with regular expressions, or not to be, right, defined and not defined, that's fine, right? But what we're interested in is to be truthy or falsy. And if you know anything about equality in JavaScript, these are very valuable to have, right? So if it's true or not true, or not null, but it's not defined, one or the other, they're both the same, blah, blah, blah. So really good stuff. You can also group things. If you're used to before test and after, they have before each. So whenever your test runs, every single function, you want something to be set up first, or a fixture, or a DTO, or a mock, or whatever. You can set it in before each. And when each function is done, you can run the after each. So they have that as well. You can also nest your suites within suites, which is kind of cool. And if you wanted to quickly skip some things, you put an X in front of it. And so it won't run it, but it will report the ones it skipped, which is really nice. You just do a quick find and replace call today. Spies are nice, so they have their own built-in spies, which are similar to mocks, where you can identify if a function was called and with what parameters and how many times. I couldn't get it to work, but I've in some of the sample code I got it to work, and this is just really, really helpful if you don't feel like setting up mocks. Since JavaScript's dynamic, it's very easy for them to do this under the covers. So really, really helpful stuff. And I guess the last thing I wanted to show was where is it? The bottom? Not the matchers. They have some mocks, but that's not really what's fascinating. What's fascinating is, asynchronous support. So if you wanted to put a poor man's integration test, where you actually have real services or real objects that have some form of asynchronous, they support that out of the box, right? Which is great. It runs, it waits for the timeout, and then it calls the runs function with your actually, expect value, right? So it's all nested inside your test of it. So everything you need to write a unit test suite with CI is all here, man. Jasmine's great. And because it's so popular, there's a lot of adapters. So if you write test in a different format, there's adapters for it. WebStorm has integration. So even though WebStorm likes JS Test Driver, they have a Jasmine adapter. So Jasmine's just really nice because it's so well known. Okay, so that's what Jasmine is, and I'm going to show you some tests written with that. So let's take a look at that. So let's show you the spec, also known as suites, but in Jasmine they're called specs. You'll notice I have folders here. The root directory is Java.js, and basically my packages are one level deep. So when I say package, I mean folder. If you're used to Java or ActionScript, you'll know what I mean when I say package. So spec / or dot or activate device spec. You'll notice I have my describe function here, and what it does is it says, all right, this activate device service, and I set up some variables I need up here. I need some fake responses from the server. Before every single unit test is called, I need to instantiate the service. I need to give it an event bus, which if you're familiar with Backbone or PureMVC or Robot Legs or really any framework that has some form of messaging, that's what this event bus is. It's a single instance that everyone uses to talk to each other, right? And after every single one, I null it out. So when I have a brand new service that's nice and clean and fresh, every single service call. So first, did my class structure work? Now, usually in most languages, you don't have to validate your class works. Like, it'll throw a null pointer exception. JavaScript is whacked, and everyone has their own ways of creating classes and everything else. So the first thing I do is say, if I instantiate a class, did the instantiation even work? Again, this is why you write unit tests for JavaScript, okay? Doesn't throw an exception when I receive a successful response. So I'm not mocking the AJAX call, but I am pretending that I instantiate the service and then call the response, right? The onActivate device service. Since everything in JavaScript's public, for the most part, unless you do the vars inside the constructor, blah, 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 I can fake that. So I can get the JavaScript from a successful response, throw it, and say, hey, you're not going to throw an exception. You're not going to puke on the JSON. You're not going to, access node doesn't work, right? You're just not going to throw an exception. I don't want you to explode, right? This goes back to my blog post of not creating grenades. If you're going to create a class, don't let it explode, okay? So if I give it an error response, right, I take the JSON, I parse the error string, which is way up here. If you're curious what this error response, all it is I have some fake responses from the server, okay? So if the server sends back the JSON of an error, it'll look like this. It's basically a JavaScript object that the AJAX and jQuery automatically parse. If I get a success, it'll look like this, right? Very similar. It's an object. They all have response. They all have a type. And the successes have a body, and the errors have an errors with a list of things that went wrong, right? So this factory validates that I can take these JSON responses and I can pass them to this and it doesn't break, right? So I expect this callback not to throw. And what this means is run this callback function and it better not throw anything, right? So it's the same thing for passing in an error. It's also the same as passing in null. Notice if I, for whatever reason, the server returns null or the JSON parser fails because it's a 500 or whatever, but it still triggers success because it wasn't a 404 or 500, I don't want that to explode. My server should be able to handle a null response, even if it's in success, and generate the correct message, right? I want this thing solid. I don't want classes to explode my face. Now, you might say, well, look, I'm in Java, we have throwable. Or I'm in ActionScript, we have global exception handling. Well, JavaScript doesn't have that. They have global exception handling in terms of reporting. You can actually capture error on the window. But browsers, even Chrome, is notorious for swallowing exceptions and not giving a clear indication of where the problem happened. Now, if everyone on the planet used the latest version of Safari, most of those problems go away, but they don't. If your code's running on an Android device, even with those neato plugins, it's very difficult to tell what went wrong. It's easier to have a log or a trace to actually tell you where it went wrong rather than trying to debug JavaScript on a device, right? That's what you want to happen. You want the code to talk to you. So these errors, if they do occur, are logged, but I can at least verify that it's not exploding, okay? So every single one of these tests is going to test every aspect of my service. And here's where I had spies fail, but I can still verify that it did call a callback. So again, if you're understanding Backbone with event buses, I can verify that it called my callback. So if you know anything about Backbone, you can register for, it's kind of like if you're used to Flash, it's add event listener. If you're C#, it's like the plus where you add an event handler. In Backbone or underscore, it's called on. So they have on and off. I want to listen for this event, and this is what you call whenever it fires, right? So when I call success with successful JSON, I want you to call my success function. Notice it says success, not error. I test the error further down the line, okay? And finally, I want to detect that it parsed my device from a successful response correctly. It's not null. So you're basically being solid on all these. And finally, this goes back to learning JavaScript. I want to verify that creating a new class is, in fact, a new instance. Now, this is important. There are ways of creating singletons or static classes in JavaScript, which they're, in Java purists, they would say that's not a static class. Well, yes, it is. It has all the same behavior. If it looks like a duck and walks like a duck, it's a bloody duck, okay? So I can verify that this is a true class that creates a true instance and has different instance variables, right? So that's basically a spec or a test suite with tests within it with before and after and some setup work, you know. The test runner, it's just an HTML page, right? It requires no weird servers or anything. I instantiate my logger because I want to log things out all over the place. This is the only global variable I have in my entire app. This allows me to get away with logging in IE and not exploding things. All the purists who, or the hipsters who live in Brooklyn, they use console because all they have to do is target WebKit. Well, I'm not that lucky. I don't live in Brooklyn. All right, so let's go down to the Jasmine runner, blah, blah, blah. So we're using require to set up some initial classes. When it's done, we execute Jasmine. This is really it. Now notice this is bad news bears, okay? You shouldn't use console, but whatever. Let's just forget it. So Jasmine execute, okay? It runs this response factory spec. We can run all kinds of specs. So let's look at a more simple one if that was a little overwhelming. So if you look at the simple spec, it just has a simple test. It uses strict. And it has A is in fact hello world and B is hello world. So let's run this. Let's go back to our Jasmine unit test and say spec. Let's run that simple spec and see what it does. We'll go to Yes, I know there are plugins for this. Yes, blah, blah, blah. All right, so notice it says passed one spec or one unit test suite was successful. Inside that test suite, the single test that I ran, A is in fact hello world and B is not null. Fantastic. And it's green, the dot shows it worked. You can also click on them to actually run just that particular test with deep linking, which is kind of cool. So again, what did it do again? It just validated that when I say A equals hello world, it is hello world. Now, if I say B is not null because I instantiated it, cool. Let's break the test. Now, here's my favorite. I save the file, I hit Apple R, it still works, right? Let's clear your cache because it's what cool people do. There you go, one failing spec, and it tells you the stack trace up to what it was. Now, again, the stack trace is only up to your function. So if you have multiples, it doesn't tell you if this one failed or this one failed. It just said the entire unit test failed. Okay. So again, this is bad practice doing multiple matchers per test, but we all do it sometimes, or at least Jesse Warden does. All right, so that's Jasmine from a high level. Let me show you my factory just so you can see another way. Here's a factory spec for device factory. It basically parses out these devices right here. So when I successfully activate a device, it's going to have a code, it's a Roku, a description, what type of device it is, a serial number that they've stored in the database, when I actually activated, and is it in fact activated or not. Sometimes it expires, sometimes you get a new device and want to deactivate an old one. So I want to parse that out, okay? So I'm going to parse my factory or run a unit test on my factory. In this case, it is a device factory spec. Before each and after each are kind of really stupid because device factory is a static class. I don't need to instantiate it. I just say equals. It's always going to return the same instance, but whatever. I just want to at least validate that that particular pattern of doing static in JavaScript works, okay? So I only need to test two things, and that is if I pass it good JSON, it gives me device DTO, right? A device. If I pass it an error string, it gives me some. It should be null because I can't get a device from a null response, right? Or an error response. And there's one other one I should write, and that is, what if I give it a null response? It should not also parse a device nor explode from that. So let's just test that real quick. Ta-da! So let's go here, back to our test runner. Let's put in our device factory spec or pin factory. And we'll, ooh, hey, I didn't have to clear cache that time. Fantastic. So you'll notice all 4 tests passed. The device factory is not null. It's actually a valid instance. I can call methods on it. It parses a valid device DTO when it has a successful response. The device factory also returns null for device DTO if it's an error response, and it doesn't explode. It returns null for device if I pass it null, right? Good. It works as expected. So let's look at a meteor one. So we'll go to the response factory. The response factory is responsible for a little bit more. Same stupid thing like test it or not, right? But validate that it's never null. I never should get a response DTO that's null, regardless of what I pass it. If I pass it an error string, it should also not be null. I should be able to pass it a success string and also not be null. So we want to validate that I never get null, regardless of what I pass the factory. He should be smart enough to interpret any whackness I send him, right? I want him to be solid, rock solid. I should be able to get the type should always be OK or error, and if it's null, he should be able to determine that that's, well, I guess it's an error if I can't determine it. If it is, the is-error property should always be correct if it is an error or not. So it should say false if I pass it a legitimate JSON request, right? Obviously, you should be able to depend on that variable. If I get error codes from the server, I need to be able to correctly parse those out, including the message, and show them to the user, right? These are all important things that I should be able to do on the service layer. And the reason this is important is that I'll have 30 classes that all depend on this factory. Just like we have millions of JavaScript web applications that depend on jQuery, right? Same thing. So that's what this unit test suite does. So here's where it gets fun. We have another one in here called Activate Device Server Spec, right? Where I test the service and this. What happens if I want to test my entire app? Now you can add a lot more in here, but we're just going to add a few, okay? Oh, I don't want to launch After Effects. We're not going to do do compositing. We're going to do class composition. All right. And everything passes all nice and clean. And all the successes and errors and logs are going through here. This is exactly what we want to say. Okay? As you can see, the unit tests find bugs in code that's in development, as well as when you change things and ripple effects that it has. And I still get all my logging in my classes. I can see here. It's a little bit nicer than Firebug. Firebug has a way better console in the way it handles things. But anyway, that is basically it. And again, each one you can go through. The point here is that out of these 27 specs, anytime my code changes, it still works. So that is Jasmine in a nutshell from a high level. So again, my name is Jesse Warden. All this code is available on GitHub. And you're welcome to fork, modify, delete, tell me something's broken, and I will do my best to fix it as soon as possible. And if you have some modifications or suggestions, some libraries. I know there's one library that worked pretty well with it. I can't remember its name off the top of my head, but yeah, there's definitely some add-ins for Jasmine as well. So I look forward to hearing from you. Thanks.